Okay, so I've got the topic 3.4 integration by parts, question 3c, the integral of e to the power of y cos squared of y dy. It's quite a difficult one. I tried a bunch of different ways. The fastest way I found is using an identity, a trigonometric identity that you'll find in your formula book. Sine 2a is equal to 2 sine a cos a. And I'll point out where we're using that later on. If we don't use that, the other ways I tried get quite long. This is quite long as it is. So first thing, a u and a dv. So for this one here, I tried a couple of different ways. The easiest way I found is to let u equals cos squared y. Now just remember, cos squared y means cos of y all to be squared. Okay, so now we differentiate that, du dy, so it's a chain rule. Now 2 comes down in front to multiply, so it's 2 cos of y, but then we also have to differentiate cos of y, which differentiates to minus sine y. Now I'll write that in a neater way. So du, so I'm going to bring my minus just to the front, just to make things easier to look at. Minus 2 cos y sine y, and then I have my dy. So I'll let my dv equals e to the power of y. So the integral of dv is e to the power of y. So v is e to the power of y. So these are my 4 important pieces. Okay, so let's set about using our integration by parts formula. The integral of u dv is equal to uv minus the integral of v du. Let me think. So the integral of u dv is what they gave us. That's e to the power of y cos squared y equals u times v. So u times v is cos squared y by e to the power of y. So I'll just write the other way around, e to the power of y cos squared y minus the integral of v du. So v du is e to the power of y by minus 2 cos y sine y. So it's e to the power of y, so I'll put my minus at the very front there, and my 2 as well, e to the power of y cos y sine y dy. Cos y sine y dy. Okay, so now this is where I'm going to utilize my trigonometric formula. So I've got a 2. So like when you're multiplying, you can rearrange these in any order. So there's no reason I can't have minus e to the power of y 2 cos y sine y. It's the same thing. But what I'm interested in is looking at 2 cos y sine y. So I have a formula that says if I have 2 sine a cos a, that's the same as saying sine of 2a in the formula book. So I have 2 sine y cos y, so I can swap that out for sine of 2y. So I have my e to the power of y cos squared y. Now I've got minus minus, so I'm going to make that a plus. I've got my e to the power of y, but now my 2 cos y sine y I can say is sine 2y according to that formula. That's a little easier. So now there's going to be a double integration by parts to help us solve this part. So let's take a departure from our main integral for the moment to get this integral here.